Hello. Today we're going to take notes eight, and we're finally going to be solving one-step equations. We have been working with the beginning of algebra for the past like 6 weeks. We started with what is a term, what are constants and coefficients, just general vocabulary. Then we switched to simplifying expressions, identifying like terms, distributing, factoring, and we are finally ready to solve equations. This is our end goal. Our end goal by the end of our unit on solving equations, we need to be able to solve an equation like this. If you're wondering, if you're curious, the answer to this problem is -1/2 or 0.5 if you want to try it on your own. But you cannot just look at this problem and guess what the answer is. Some of the questions that we're going to be working on today, you can just guess the answer, but not on the more complicated ones, which is the goal for us to be able to do. And so the whole point of us practicing to solve one-step equations is to learn how to show our work so that we're able to show our work on a more complicated one like this to find the missing value, to find that variable x. So the most important thing you can take out of this lesson is to learn how specifically I want you to show your work. I normally don't try to be bossy and mandate that you do something the exact way that I want. I like to give you freedom. I know that there are a ton of ways to solve different math problems, but when we're learning how to show work, I'm going to ask that you try to show it exactly how I am trying, like I'm teaching you today. So that's the most important thing, that we must show our work. And then I have a couple important facts we're going to talk about, and then we'll do some examples. But the way we're going to think about equations is we're going to think about equations as a scale, where the equal sign is the center of the scale. So this is the equal sign. And each side of this scale has to stay balanced. So I have a couple of examples we're going to try just so you can see how this works. But if I try to solve this problem, x plus 7 equals 10. This thing is going to be our x. I have no idea. It's like a little keychain. I don't know what it is. This is our unknown. We don't know how heavy he is, but we know that this guy plus 7 blocks, I counted them earlier, 1, 2, 3, 4, 5, 6, 7, is equal to 10 blocks. So we know that these two things are balanced. The scale is even right now. And if I want to know how much this little guy weighs, I don't want any blocks with it. And so what I can do to keep my scale balanced is if I take one block from this side and I take one block from this side, like taking one from both doesn't change the answer. So I can take those two away. And I can do it again. I can take one block from this side, the left, and one block from the right, and my scale stays balanced. The important thing here is whatever I do to one side, I have to do the same amount to the other. If I take 4 blocks from this side and only 3 from this side, then this side is going to be heavier. It's going to not be equal or balanced anymore. So if I take 4 from this side, I have to take 4 from this side. I still don't have this little guy alone, so I have to take one more, take one from here, and now I know that this guy is equal to 3 blocks. You might have known that answer before. You might have known that x is going to have to be 3, but kind of that's the process of how we're going to show the work. So if I draw a line through my equal sign representing the scale, I ended up taking away 7 blocks from this side, and that meant I had to take away 7 blocks from that side, and 10 minus 7 was 3, so x was equal to 3. That's kind of the process. So whatever I do to one side, I have to do to the other. So that's the first important fact, is that every equation is a scale. We have to keep it balanced. So please write down that first important fact. Okay, the second goal is to isolate the variable.